the entire traditional process of data science, going from the project idea, finding the data scientist, setting up the infrastructure, analyzing the data. I mean, taking years to collect the data, right? And then processing it, doing any type of feature engineering, modeling, and then finding the developers to be able to deploy the AI model. And then all of a sudden you have bad results and you have to start over again, right? Or maybe it worked out well and you're doing predictions and all of that good stuff, which I hope worked out for you as well for your particular use case. And as you kind of highlighted as well, with Neuton, we're able to start with the project idea, just upload our data, train the model, and we're ready to make predictions. So some of the advantages are being able to bring AI productions or AI into production 10 times faster. We can reduce the cost of implementation from an automated perspective, and we need less support for those models, and we've put in some lifecycle management tools to help be able to understand if your model's decaying and needs retraining, as you had mentioned, doing predictions every 3 months, and then if the model's decayed, what can we do? So the idea is, can we run a machine learning experiment with just 3 clicks, and being able to do a lot of the kind of data pre-processing that can be a lot of manual effort. I believe you had about 10 points across the entire process, from understanding the requirements to gathering the data to processing the data, creating the model, and that iterative approach. I think this is in line as well with what you were sharing as the traditional data science versus the modern data scientist. So you have data science, coding skills, how can we do data mining? What are the machine learning tools that we have available? Do we have analytical skills? And then how do we connect that with the IT infrastructure? And I feel that the customer journey and customer experience, when we look at domain, business domain expertise, so whatever vertical you may be in, it could be oil and gas, it could be retail, e-commerce, could be logistics. How can we as individuals focus on those particular verticals that we're really passionate about, and how can we apply machine learning to? How can we look at the different business problems within that? So if you are looking at retail, maybe you are looking at that customer experience, you are looking at that customer churn, and how can we understand that problem and apply these different techniques too? Additionally, creative thinking, this works really well with, Daniel, your kind of customer journey maps. I mean, preparing for workshops, doing workshops, gathering the data, doing quantitative analysis, all of those things can be applied not only to the customer journey, it could be applied to a company's AI journey. How can we go to each business unit, understand what finance and accounting is doing, understand what logistics is doing, and apply that creative thinking in those workshops to other areas of interest? And communication and leadership. So the ability to be able to communicate to business, the ability to communicate with IT and bring these skills forward. And having that AI mindset, kind of like you had mentioned, Fabio, from Satya's book, absolutely having that mindset of being able to understand the unarticulated and unmet needs. How can we bring in project management and agile to that, as well as network? So overall, we see these skills as the data scientist of the future. So I'm going to quickly jump into the customer satisfaction problem that I was mentioning earlier from an airline. So as Fabio had showcased, this is the Neuton platform. Here I've got some different solutions that I've built in the past, whether it be a bake marketing, customer churn, or in this case, customer satisfaction. So I'll just kind of quickly jump through. In this case, we'd like to create a model that is predicting the customer satisfaction. I'll just name it that, rightly so. Once we've done that, we can then upload our data set. So here I have a series of different data sets that we have done different solutions for. In this case, I have two data sets. We talked a little bit about separating our training set and then having the predictive training set. So in this case, the training set is all of the historical data of the customer journey that we have and what their satisfaction is, whether it was highly satisfied or not satisfied. So it kind of ties back to the specific use case that Fabio is working on. This is more of a generalized one, but we can go into a little bit more detail. The test data set that we have is all of the customers that we're going to want to predict their future satisfaction on. Right now, it's going to quickly go ahead and just check the data to make sure it's good. Once it says it's good, here we're able to click OK. And on the top, as mentioned before, we have 3 steps: the data set, the training, and prediction tab. Let's just quickly take a look at the data. So when we were looking at customer satisfaction, it may be categorical data for gender, the customer type, age, so a lot of different demographic information. The type of travel, we talked a little bit about this. It could be, a consumer to consumer, or it could be B2B. What class of flight, how long the flight was, etc. So we have lots of different information that we've been collecting from our customers, whether they've had baggage handling or not, if they have in-flight service, whether it was good cleanliness, for example, and then and then the customer satisfaction that ideally we would have been able to collect from a survey. So we either have the customer was satisfied, or they were neutral or dissatisfied. So this is a binary classification, kind of like, are they a high risk or a low risk customer? All we'll need to do here is select the target variable, which is satisfaction, and click next. Once we've done that, the platform has understood it's a binary classification, whether somebody was satisfied with their flight or not. And the metric is accuracy. You can choose different ones, but we'll stick with this because we'll want to accurately predict whether they were satisfied or not. And then click training. All of this is automated, so we don't need to deal with any provisioning or anything like that. The Neuton platform will do that automatically for you. We can also set up a text notification, so when our model's complete, we'll get a text and we can come back to the platform and start to understand it. I've already
this is one of the features that I like the most, to get a text when the model is finished. So I don't have to be, clicking refresh or checking the homepage all the time. I love it.
Yeah, absolutely. It's super convenient. Unfortunately, I put my mobile phone number in our demo account, so I'm getting text messages from all the solutions we're building. Here with the same data set, I've already trained a model, so let's just look at that. Here we can see the model took 29 minutes to train, and we have this model quality index that we saw earlier. This can vary depending on the data types and problems you're trying to solve and things like that, where we saw some issues with maybe balanced accuracy and things like that. Now within the prediction tab, this is really kind of where the interesting piece was. And earlier we saw the feature importance matrix, which is really cool. I'll go into it a little bit. Some of the things that we didn't see here were looking at the prediction tab. I've already enabled prediction. We've added this particular feature to help people like data analysts or business analysts be able to do predictions on the fly. So in this case, I would simply upload my customer satisfaction test. So this would be all of the customers I want to predict on how satisfied they are. So I have already uploaded this and enabled prediction just so we can save a little bit of time. Going a little bit deeper into what Fabio was talking about with each individual prediction. So here, Neuton has all of the features that from the test data set that we have. Everything here from the left is what Neuton has predicted and provided within the platform. So we can see different individuals who were satisfied and how probable they are of being satisfied. In this particular case, customer number 5 was neutral or dissatisfied. So this might be something we want to look into a little bit deeper. And the interesting piece here is the probability of them being neutral or dissatisfied is 75%. The probability is 25%. So this might be an interesting customer that we can look at and dive a little bit deeper. And that's where we've created what we call our model interpreter to understand this individual prediction. Here we can see they were neutral or dissatisfied with a 75% probability. Now, here we have a lot of the features that have influenced this particular prediction. In this particular case, we're looking at in-flight Wi-Fi service. So whether somebody on the flight, what quality of Wi-Fi service that they have. In this particular case, it was ranked as a 2, and they were neutral or dissatisfied with a 75%. Now, if we are able to change this value to a 4, so much higher quality of Wi-Fi, we would now have a neutral or dissatisfied of 60%. So we can see that there's some business insights or actions we can take on being able to potentially be able to provide better in-flight Wi-Fi service. We can also see different features of the type of travel, whether it was business or not. In-flight entertainment, this particular individual was ranked at a 2. If we were to up the in-flight entertainment to a 4, then we would actually predict them with a 55% probability of being satisfied. This will allow us to look at different features of individual predictions to help us gain business insights. There's just a couple of other things that I will show here. And we can also take a look at the chat and Q&A afterwards. So here is our historical model to data relevance indicator. So every month, I'm predicting the satisfaction of our customers, right? Maybe after month 2 or 3, the data starts to change and the model is no longer relevant. This percentage, say, will drop to 70%, and the tree will kind of get withered and turn yellow. So this might mean we want to now retrain a model. So this is something that we can use for a model lifetime management tool or lifecycle tool. As we saw also from a feature importance matrix perspective, we can see how potentially Wi-Fi is extremely important, as well as we've got type of flower or in-flight entertainment, gate location, whether they had baggage handling or not, etc. The last thing I will show is also an analytics tool that we've added, what we call as our exploratory data analysis. This will give you an overview of all of your data. So we have 2,700 neutral or dissatisfied and 2,000 satisfied. So it's a fairly balanced data set from Kaggle. And then we can also see if there's missing values. So there was a very small percentage of missing values. We can look at continuous data. So how is our age distribution? We can see a lot of people in the 20 to 30 range, as well as up to 40, and how that may influence the target variable. Additionally, we can look at the flight distance. A lot of the flights were here under 1,000. If we look at how the flight distance is in relation to the target variable, we have instances for neutral or dissatisfied up to about 1,000 miles. Above 1,000 miles, it looks like most people were satisfied. So we could look at, what are the flights below 1,000, where we have both cases of satisfied and dissatisfied. Additionally, when we're looking at categorical data, so in this particular case, whether it was business travel or personal travel, we can see whether they were neutral or satisfied. So from personal travel, we have a lot of neutral and dissatisfied, and a little bit of cases of satisfied. And then business travel, we can see a large distribution of satisfied customers versus non-satisfied. So we might want to take a look at what we're doing in business travel and see if we can apply some of those techniques to increase customer satisfaction as well. This is just a snapshot showing the percentage of satisfied versus not satisfied. This is one of my favorite ones. It's our correlation heat map that helps show us what features are correlated to the target variable. So in this particular case, online onboarding type of travel are fairly correlated with the target. We can also see cross correlation between cleanliness as well as seat comfort. In some cases, if some particular features are highly correlated, we might want to take a look at that and see if we want to remove them, if it may cause some issues with our model. And we also have a missing value. All of the dark rows, as we saw, it had a very few missing values. If there were more missing values, there may be a lot of white dots along here. And here as well, we can just see very few missing values as well. So that was just a little bit deeper dive into the customer satisfaction use case that we did in relation to kind of what you had shared, Fabio, as well. So thank you, everyone, for joining, Fabio, Daniel as well. We'd love to open it up for any discussion points, Q&A. And so when we look at a data set, as Susan had showcased, there's a lot of different things that are going on. So in this particular case, we've got, our client IDs and some various different information. And so what are some of the things that a Neuton can help with? So in this case, columns with 100% unique values will be dropped. So, an ID like columns, for example, columns with a constant value will be deleted. So in this case, all of these values are 1. So this isn't going to help us when we create a machine learning model. Additionally, an identical column will be dropped after scaling. So you can see that the value in column 3 is doubled value of column 2. So here you can see that the column is doubled. So this won't provide value. And then also Neuton will help handle missing values. So we'll create machine learning models to fill in these missing values. Then also in different cases where Susan had highlighted, hey, in a particular column, we might have this error, right? We have somebody accidentally keyed in some letters as opposed to the numeric values. So we'll go ahead and detect those, remove them, and then predict on a new value. And then also another issue with missing values, if there are too many missing values within a particular column, if there's more than 50%, we'll just automatically drop those. And then finally, we will have rows with these different outliers or numbers that aren't fitting within the data set. So here we have these huge numbers where in the target we have maybe 5,000, but here we have a very large number. Same thing here in column 7. We have 2, 4, 6, 8, but then all of a sudden we have 10,000. So this won't be very useful for us. So we'll go ahead and jump into a live demo example. Here's a QR code to try the Neuton platform for free. We have lots of different preloaded data sets in there for you to try out across different industry verticals. Today, we're going to be looking at a famous data set for predicting house prices in Boston. And so let's go ahead and jump into the platform. So this is the Neuton platform. It's completely cloud-based, so you can leverage it via the web. And all of my solutions that I've created here are tile-based. and everything's on Google Cloud Platform. So all of the infrastructure is handled automatically. And all we need to do to get started is we go create new solution. In this case, I'm going to do house price prediction. So we're going to look at all of the different features within the Boston market about houses, whether they're multiple stories, how many rooms, how many square footage, and then the historical price for those houses. And then that way, as a realtor, for example, when I'm looking at new information on houses, I can take this model and then predict on what the new house price should be. And then there's some data and analytics involved as well. So once I've done that, I can either upload my data set, I can select from storage, or use a preloaded data set, which I'll do for the sake of demonstration. So here, if you, when you log in, you'll be able to get access to all of these preloaded data sets to try out the platform for free. In this case, we're going to do a house price prediction. And before I continue, I just wanted to show you kind of what the data set looks like. So here we have information about zoning, what the lot frontage is, the lot area. As you can see, we even have text data, right? So all of this is going to have to be taken care of before we create a machine learning model. So as you can see, there's lots of information about the houses. And then finally, we have the historical house price of the actual value of those houses at the time. In this particular data set, we have about 1,400 different houses that we're going to learn on. So now we just hit OK. So within Neuton, there's 3 easy steps for you to be able to create these powerful and predictive models, and we'll be able to look at this as well. I see some chats coming in here. I'll definitely address those at the end. So yeah, there's 3 easy steps: data set, then we train, and then ultimately we want to predict what the new house prices are. So the last step in the data set tab is we select the what we're trying to predict and train on. So in this case, we're going to want to predict what the house price is. Now, the next step is training. The platform has understood that it's regression, and the metric is root mean squared log. So in this case, if we weren't using a preloaded data set, we would be able to select different task types, but for all intensive purposes, you don't need to, and then you just click training. Now what this is going to do is it's going to begin to learn on all of those. Well, first it's going to do our automated pre-processing, which I just showcased in the PowerPoint. And then also, if you want, you can get a text notification of when the training is complete. Once it does the pre-processing and feature engineering, if you want, it'll then train a predictive model. After that, you can go ahead and start predictions. In this case, it may take a little bit of time to train the model. So what we're going to do is I've already pre-trained on this data set. So let's just take a look here. So this took about 8 minutes to train the model, and we looked at the data that was before pre-processing. Let's take a look at what it looks like now. So after the automated pre-processing, as you can see, it's actually changed all of the text into numerical values. It's filled in the missing values, etc. So that's kind of what the data will look like after the automated pre-processing. We've also baked in some analytics tools in order to help you understand the data maybe before you do the prediction. So in this particular case, what we have here is our exploratory data analysis. We'll give you a nice snapshot of your overall data. So in this particular case, the maximum house price was $755,000, the minimum was $34,000, and the mean was about $180,000. We can see we had 1,400 rows, 81 columns, etc. In this particular case, we had about 7,000 missing values that we've been able to handle, or about 6% of our total data. In addition, we also provide what we call continuous data. So on this particular case, we're looking at the general living area distribution in relation to the target variable. So what does this mean? So within houses, right, we have a general living area. And so in this case, most of the houses fell under about 1,200 square feet for the general living area. And on the right here, on the bottom, we have our general living area, as well as the house price in the vertical. So you can actually see somewhat of a linear, actually pretty well linear relationship of the larger the general living area, the higher the house price. And you can do this with all of the different features as well. Some cases it might be informative, in some cases it might not be. We also provide information on the discrete data. So this is kind of a nice snapshot of the categorical data, if you will. So in this case, it was, did the house have central air conditioning or did it not? So 1 or a 0, or a yes or a no. In this case, a large amount of the houses did have central air, and a few didn't. And then on the right, if we look at it in relation to the target variable, we can see that quite a lot of the houses that did not have central air sold for under 180,000. And then houses with general or central air, excuse me, they sold from all the prices up to 175,000. Here, this is a violin plot. So here we can see the general distribution of the sales prices. And then all of these outliers, say some of the houses that sold for 750,000, we actually remove those automatically in the data pre-processing. We also provide a correlation heat map. This will showcase all of the features that are correlated with the target variable, as well as different features. So in this case, the overall quality of the house was highly correlated with the sales price. If we look here, we can see the first floor square footage is highly correlated with this particular feature as well. And so in this case, certain features that are highly correlated, we might want to remove. One of the other kind of cool visualizations that we have as well for your data analysis is the missing value heat map. So this is actually a snapshot of the entire Excel sheet. Anywhere there's white, there's missing values. And so here it's a little bit easier to see. So for the feature alley, you can actually see a lot of missing values, which are white. And then for some of these ones that are darker, are a lot more filled in. So we might want to say, hey, you know, we don't have much data on the alley, so maybe there's other areas we can go and collect data to fill this in to create a stronger model. And then we also show some different outliers and then the overall model quality. And in this case, we use RMSLE. And if the arrow's down, then you want a lower one. So this is pretty low, so that's good. So that's our exploratory data analysis. But of course, what we all wanted to do here is make predictions, right? Because we have all of our historical data, we had the target variable, but now we want to predict on that. So you can just click this button to enable prediction. I've already done it just to, because it takes a couple of minutes for demo purposes. You can download the solution and deploy it on a machine or on an edge device. You can also access it via REST API. So if you want to make predictions every month, you can set up and call to the cloud. And we provide the sample code that you would need to do that. So you really, you don't need to know coding. And as you can see, all I've done is a couple of clicks and I've been able to create a predictive model. No code necessary. So once you want to do predictions, you click start. And then right now, I'm going to select my test data set. So there's two data sets, the one with all of the historical data, including the sales price. And then there's all of the new data that does not include the sales price because we don't know. So now we're going to upload that and predict on it. So normally you would just click start, but I've already created predictions And so let's see what the Neuton platform has produced. So in this case, everything to the right is all of the data that we've uploaded, the new data that we want to predict on. And then everything left of this area is the new predictions that Neuton has created. So in this particular case, for the first house, we've predicted this 130,000. Now, once you've done a prediction, you may want to understand, why did my model make that prediction, and what are the things that I can do to help with that? So in this case, maybe we want to look at house number 4, for example. It predicted at 179,000. We can use what we've created, which is our model interpreter. This will allow you to understand the prediction from compliance purposes, or even from business outcomes. What can we do? So here we have all of the top features that are influencing the predicted value. So in this case, we predicted the house to be 179,000. Now, one of the features we have is the overall quality of the house. In this case, this house was rated as an overall quality of 6. Now, if we were to adjust the overall quality of the house to an 8, now we would predict the house would sell for 219,000. So if you think about it, as a realtor, what are the different things I can do in order to improve the overall quality of the house to ultimately get a higher sales price? And is the investment of raising the house quality from a 6 to an 8, am I able to invest, say, $10,000, right? So instead of 180,000, it would be 190,000, but I can actually sell it for 219,000. So that's just kind of a little bit of an example of how you might be able to, look at the data, make adjustments, and then make business, actions from that.